Due to the length of my presentation, I couldn't send it in one video, so this is the second part of the lesson on 8.8 optimum volume and surface area. Extra example 1. Aileen has 720 centimeters squared of cardboard. She wants to make an open box so it would have 5 sides with the largest possible volume so it can fit more things. What should the dimensions of her box be, and what will the volume be? First, determine the surface area, which is 720 centimeters squared. Since there will be one side missing, we can put this into the formula. So surface area equals 6x squared minus x squared, which is the area of one side. Simplify this into surface area equals 5x squared. Now that we have the formula, put the surface area in and solve for x using inverse operations. Plug this into the volume equation and solve to get 1,728 centimeters cubed. Therefore, the dimensions of our box should be 12 centimeters by 12 centimeters with a volume of 1,728 centimeters cubed. Extra example 2. Luke is making a closed box with a volume of 658.503 centimeters cubed. He wants to have the least possible surface area and for it to hold a sphere that fits perfectly. He also wants to fill the empty spots around the sphere with sand. Luke needs to know what the dimensions of his sphere should be and how much sand he needs. First, determine the volume, which is 658.503 centimeters cubed. Next, cube root it to get one side length, which is 8.7 centimeters. Now, if the sphere fits perfectly into the box, then one side length will equal the diameter of the sphere. The formula for volume of a sphere is 4 over 3 pi r cubed, so we need to find the radius, which is half the diameter, which equals to be 4.35 centimeters. Put this into the formula for volume of a sphere and then solve to get 344.8. Here we have the same question continued. Now that we know the volume of the box is 658.503 centimeters cubed and the volume of the sphere is about 344.791 centimeters cubed. The empty space where the sand will go can be calculated by taking the total volume of the box minus the volume taken up by the sphere. Substitute the numbers in, and the answer is 313.7115 centimeters cubed. This is the amount of sand that will go around the sphere. So, the answer is that the box should be about 8.7 centimeters by 8.7 centimeters. The sphere should have a radius of about 4.35 centimeters and a volume of about 344.8 centimeters cubed. And he needs about 313.7 centimeters cubed of sand. This next example is from the textbook. Parenhoy is making an ice sculpture with 8,200 centimeters cubed of ice. It will be a prism with either a square base or a cylinder. What shape will have the least surface area and what dimensions will it have? So first, let's do the square base prism. Determine the volume, which is 8,200 centimeters cubed. Substitute that into the volume equation and use inverse operations doing the cube root of 8,200 to get our answer, which is about 20.2. Now that we know the side length, substitute it into the surface area equation and solve to get about 2,439.8 centimeters squared. Next, the cylinder. Determine the volume, which is still about 8,200 centimeters cubed, and put it into the equation. Solve using inverse operations again to get about 10.9. This is the radius. Put the radius into the surface area equation, and then solve to get the total surface area, which is about 2,164.6 centimeters squared. Now that we know the dimensions, restate and compare them. Looking at both surface areas, we can see that the surface area for a cylinder is smaller than the surface area for a square base prism. Therefore, the cylinder has the least surface area with a radius of about 10.9 centimeters, a height of about 21.9 centimeters, and a total surface area of 2,164.6 centimeters squared. The last example states, what is the greatest possible volume for a cylinder that is missing a top with a surface area of 500 millimeters squared? First, define the surface area. Next, put it into the formula But since the top is missing, we have to take away pi r squared, which is the area of one circle. This changes the equation to surface area equals 5 pi r squared. Substitute the surface area in and use inverse operations to solve for r, which is about 5.6. To calculate height, do 2 times r. So our height is about 11.3. Substitute this into the surface area equation and remember to take off pi r squared because it is missing a top. Solve to get 500 millimeters squared. Because the answer matches the original surface area given, it is correct. Last, put it into the volume equation to get the answer. Therefore, the greatest possible volume is about 1,128.4 millimeters cubed. This last page is just a very quick review of what we went over throughout the whole lesson and all the formulas that you will need to answer any questions given.